Hello, my name is Alexander. I'm delighted to demonstrate our tool called Jump, which we have implemented on top of the Eclipse environment. Jump aims at bridging Java's annotation mechanism with UML's lightweight extension mechanism. It allows developers to automatically apply UML profiles on UML models, which are generated in the context of reverse engineering scenario. Let's assume the customer class from the well-known pet store application that we want to lift to the UML level. By applying a straightforward approach, we obtain the corresponding class diagram. However, what is missing in the generated model is the entity annotation of the application code. With Jump, annotations are also lifted to the UML level by applying the UML profile and the defined stereotypes, which correspond to such applied annotations. Therefore, our approach also allows developers to automatically generate UML profiles from Java-based libraries which embrace annotations. The generated UML profile for the Java Persistence API provides the entity annotation in terms of a stereotype, which extends the UML metaclass type. The extended metaclass needs to conform to the defined target of the annotation declaration. By applying the entity stereotype to the customer class, we directly exploit UML's native extension mechanism for turning the reverse engineered UML class diagram into a profiled UML class diagram. Now let's switch to Eclipse and perform the introduce discovery process in Jump. To generate the UML profile for the Java Persistence API, we execute Jump on the source code of the Java Persistence API. Let's create a new launch configuration, select the project, we want to have a UML profile and run it. Well, let's have a look at the generated entity stereotype by using the Papyrus model editor. For that reason, let's create quickly a diagram. For the purpose of this demonstration, I've already dragged the entity to the canvas. As expected, the entity stereotype extends the metaclass type. However, to precisely restrict the application scope of the generated stereotypes according to the original Java annotation declaration, we need to add further constraints because not all Java element types correspond well to a UML metaclass. One example is the heterogeneity between Java's and UML's scope of type. As the scope in UML is broader than in Java, we add constraints to the respective stereotypes. Once such a stereotype is applied, these constraints are validated at the modeling level. Now, to make generated UML profiles publicly available, we introduced what we call the UML profile store. Currently, it is a collection of UML profiles we have generated throughout the evaluation of our approach. It's available in terms of an Eclipse plugin, which exploits extension points. In this way, developers can directly use the UML profiles in the Papyrus UML model editor. In fact, for the profiled UML model discovery, which I demonstrate next, we exploit the UML profile store already. Let's proceed with the pet store application from which we want to reverse engineer the profiled UML class diagram. By executing again Jump on the pet store application code, we obtain a profiled UML class diagram. Let's create a new launch configuration. Select the pet store application project, and now we want to have a profiled UML model and run it. As you can see, the pet store relies on several different annotation-based libraries, as 11 different UML profiles from the UML profile store are applied. If user-defined annotations are declared in the reverse engineered application, Jump generates also an UML profile for them. As this is the case for the pet store application, we obtained the corresponding UML profile, which is also applied on the pet store UML class diagram. Finally, let's navigate to the customer class by again using the Papyrus UML model editor. For that reason, I've already generated the diagram from the pet store model in a similar way as before. On the canvas, you can see the customer class with all the applied stereotypes, including the entity. As I mentioned before, you may also select UML profiles from the UML profile store and apply them on the model. For that reason, let's assume we want to exchange the entity of the Java Persistence API by the entity of Objectify, which is a data management framework for accessing Google's App Engine data store. Let's select the entity of Objectify. And now we have the entity from the Objectify UML profile applied. To briefly conclude, our approach allows developers to jump from Java to UML, thereby exploiting UML profiles to also capture annotations in Java.